This screencast is on constructing redox half equations. So first let's start with what is a half equation. So a half equation tells part of a story of a redox reaction. It tells us either the reduction or the oxidation process. Since all redox reactions involve electrons being transferred, half equations always contain electrons. And if you have got electrons on the left-hand side, then that's a reduction process and a reduction half equation. And if they're on the right-hand side, then it's the opposite. It's an oxidation process. So let's think about how we do this by looking through an example. So here we're asked to construct a redox half equation for the reduction of chromate ions, and you're given the formula for that to chromium 3 ions. So the first thing to do here is to write out the bit that you know on the left hand side and the bit that you know on the right hand side of the equation. So we're going to put our chromate ions on the left. They are CrO4 2-. Leave lots of space because we know we're going to have to add things around it, and that's going to Cr3+. So now we need to think about what the steps that are involved are and what order that they go in. So the first thing you have to do is to balance the atoms, and then after that you can balance the charges. If you do it in the other order, if you try to balance the charge first, then you can end up with the wrong answer quite easily. The other thing that you need to remember is that in order to do this process, to do this balancing process, you can use coefficients, so you can put big balancing numbers in, but you are also able to add 3 things and only these 3 things. And they are hydrogen ions, water molecules, and electrons. So you can use those to help in your balancing alongside using coefficients, big balancing numbers if you need to. So let's go back to our chromate here. So on the left I've got 4 oxygens, and on the right I haven't got any oxygens. So I'm going to have to use the only species that's got oxygen in it that I'm allowed to add, which is water. So I'm going to need to add 4 H2O there. Now the consequence of that is that I'm now not balanced as far as hydrogen's concerned, so I'm going to put 8 H pluses on the left. So I'm now balanced for atoms. I can then move on to balancing the charges. So overall, on the left hand side here, I've got 8 pluses and 2 minuses. So overall, this left-hand side of the equation is 6+, and the right-hand side of the equation is 3+. So I need to make those match, and I'm only allowed to use electrons to do that. So electrons are going to take charge away. So I'm going to put these electrons on the left-hand side and reduce that overall 6 positive charge so that it can match the 3 positive charge. So if I add 3 electrons there, and I do a little bit of a recount here on the left, I've got 8 pluses, take away 2 for the chromate here, so I've got 6 pluses, and then another 3, that leaves me with 3 pluses, and that matches the 3+ there on the right, and that equation is complete. So let's quickly just summarise what we did with that. So balancing, atoms, then charges. Balancing is achieved using just a few things. First one being coefficients for balancing, but mainly it can be by adding only H plus, H2O or electrons. You can then look at the next part of the video and have a go at some examples to check that you understand this. Here are the in-video exercises for this redox half equation screencast. There are 5 for you to have a go at. Sketch them down on some paper, have a go at them, pause the video and check back for the answers in a minute. So hopefully you've had a chance to get those done and you're just for the answers. Let's have a look at question 1. On the left hand side we have Fe2 plus, on the right hand side we've got Fe3 plus. So we don't need to balance any atoms. All we need to do is balance charge by adding electrons to the right hand side. That means that the left hand side has got a 2 plus charge, and then the whole of the right hand side is 3 plus, take away 1 for the electrons, so that's 2 plus just by doing that. Second one, a little bit more complicated. On the left hand side we've got 2 H pluses and 2 hydrogen atoms and 2 oxygen atoms. So we're going to need to put a coefficient in here. That's the simplest way of balancing this. Don't try not to add things unnecessarily. So I wouldn't be going here seeing that it wasn't balanced and start putting water into it. So try to use coefficients first. So we're going to put a 2 in here. That means that the left hand side is neutral, the right hand side is 2 negative, so therefore to balance that up we're going to have 2 electrons on the left hand side. Didn't leave myself very much room for that one. Okay, next one, much more complicated. We've got 2 vanadiums and we've got 5 oxygens on the left hand side, and we haven't got anything like that on the right hand side. So let's just deal with the vanadiums first. So we'll use a coefficient 2 in front of that vanadium 2 plus. We can only get oxygens by adding waters, so we're going to add 5 water molecules there as well. So I am going to run out of room. So the V2O5, I have got 5 H2, so I've got 10 hydrogens on the right hand side, so I'm going to need 10 H plus on the left. And then we're going to have to figure out what's happening with these charges. I've got 10 pluses on the left. I've got 2 times 2 pluses on the right, so I've got 4 plus on the right. So I'm going to have to turn my 10 pluses into 4 plus, and the way I can do that is by adding 6 electrons. I'm actually going to write that out underneath a bit neater so that it makes a bit more sense. So that'll be V2O5 plus 10H plus 6 electrons, going to give 2 V2 plus 5H2O. It's just a bit neater and a bit easier for you to see. I think I'll have to do the same with this one. In fact, I'm going to give myself a bit more room already now with this, because I know I'm going to need it. Okay, so going back to this one, question 4, we can see that we need 4 oxygens on the right, and the way to do that is by using water molecules. That means I'm going to have to come back over to the left hand side and add in 8 H pluses. So counting up 8 H pluses and a minus, so I'm 7 H plus here on the right, on the left. On the right here I'm 2 pluses, so to even those up, I can add 5 electrons, so that I am 2 plus on the left and 2 plus on the right. Again, with this question 5, I'm just going to delete that and move it over a bit so I've got a bit more room to do the work on it, because I think it's going to need a bit more. Okay, I think this one is the most complicated yet. We have to balance the chromium to start with, so put 2 Cr3 plus. We need some water molecules. We need 7 water molecules to get our 7 oxygen atoms, and that means that I'm going to need 14 H pluses on the left. Then we've got to figure out what's happening with the charges. 2 minus 14 plus means that here on this side I've got 12 plus, and here on the right hand side I've got 2 times 3 plus, so I've got 6 plus. So I need to add 6 electrons to the left hand side. So those are all finished, and hopefully you have followed the reason why I've done everything that I've done there.